I'm going to talk today about AppSensor project, but more specifically that is allowing an application to defend itself in real time from attackers. What I think we can do with applications as the next step after we secure them. Don't get the wrong idea that I'm saying we don't secure our apps, because we have to do that. But what I'm thinking we can do next is detect a bad guy in our application while he's looking for a vulnerability, and then kick him out of the application. So just think about like your bank. Your bank is not immune to every type of possible attack to get inside the building. But they don't have to be, because they watch you with cameras and they arrest you. And that's kind of the idea of AppSensor, is giving applications the ability to see a bad guy and get rid of him before he does bad things. The project has come quite a long way. This might be one of the last times I present it, because it's in really good shape now and it's ready to go. And I'm looking for user feedback after this. It's been under development for a couple years now. We have code. The code now is ready to work with ESAPI. You guys are aware of ESAPI? Is anyone using it? Okay. So this is ready now that you can drop in the AppSensor jar and you're good to go right away with ESAPI. And in another version or two, it'll be in ESAPI as an extra jar, ready to enable by default. So we're in really good shape. Here's the obligatory OWASP front slide, because it's supposed to be there. Here's the other slide. So we're going to talk about the power of this idea of application-based intrusion detection. We're going to talk about the status of ESAPI and AppSensor. I'm now releasing code on how to do this, because I don't like to say, here's something, good luck. I have an entire WebGoat-style code demo for it. That's on Google Code. You can download it. It's ready to go. So we're going to talk about that. And then we're going to talk about how these ideas are being used at Mozilla right now. So this is not all theoretical stuff. Like, companies are using it now, and it's providing lots of benefits. So we're going to talk about those things. I somehow created 50 slides, which is more slides than I have minutes. So we're going to see what happens as far as how fast I talk and how quickly we go. Before I get into everything, I just wanted to thank the contributors and core teams of AppSensor. They're all listed up there, and I'm really sorry if I missed somebody. Please heckle me, and thank you if I didn't list you. So first off, the power of this idea of application intrusion detection. Right now, the current status of how we defend apps is not so good. If you're looking at these bullets and those are your strategies, like if you wait to know you've been hacked by watching newspaper articles, that's probably not the best way to do things. And that's unfortunately how we do most of the stuff. Like, if you called up someone in charge of your app and said, are we being attacked right now, could they answer? Would they have any way of even knowing? And that's a problem. That's a problem when you think about it, because right now we're just building an application, we're building it secure, which is great. And like it says, we're just hoping for the best. We're hoping people don't find flaws and don't get in. And we can do a lot more than that. So when we break it down into more of a kind of a threat model type approach, we see there's lots of different ways our apps are under attack. And we can categorize those into different logical areas. For example, an attacker could attack the request itself by modifying the parameter or the method from a get or a post to something else. There's always that discussion of like the Jeff method, and that actually exploited some different implementations, some web servers on how that was handled. So they can attack the requests, they can attack authentication, session management. There's also lots of attacks in access control. If you send a URL with ID equals 4 and change it to ID equals 6, if your access control is coded correctly, you'll get an access control exception. The user won't be able to do what they wanted to do, or the attacker won't get that information. And that's great, the application's secure, but we're missing an opportunity there to say, wait, why did you change that number? I mean, maybe it's in the URL, and maybe you decided you'd try and be clever, so we should say, that could be a bad person just poking around. But perhaps if that access control parameter is in a post variable, like, you can't accidentally change a post variable. So you know that that user is up to no good by intercepting the message and changing the post parameter. So these are the kinds of things that we need to think about. Where are attackers looking for problems? And we know we don't have issues there, or we hope we don't have issues there, but are they doing something that's out of the normal flow of the application, and are they trying to be bad? And as you see, there's lots of different places we can continue to look for these bad actions. Input validation through each different page or JSP or however you have the application designed. You're doing validation based on what you think the application should receive. And in some situations, you shouldn't receive, script, well, we could say alert document.cookie. I mean, the attacker could be looking for a basic proof of concept. Maybe that's a situation, again, where you say, why are you sending this to me? Maybe you're bad. And we also have, business logic attacks. If a user goes outside of the normal flow, if they start jumping around in the flow of the application in ways that shouldn't happen, could be an attack again. So overall, we have all these different ways that an attacker is going to look to exploit flaws in your application or look for these flaws. And again, right now, we're just hoping that we don't have them and hoping that we've coded everything securely. So what I'm saying with AppSensor is take these different points where we could be attacked and add detection. Kind of like miniature alarms or tripwires all throughout your application that looks for deviations from normal flow and looks for possible attack probes. And the goal is to do this with a low false positive rate. We can't, fire on a single tick in a username. We know that very well could be normal, but it also could be in anywhere, a fat finger type situation. A user could accidentally do that. So what we need to do is look for things that have a very low false positive rate that we're very confident that the user has taken intentional action to do something bad, such as, modifying a post parameter, changing something that the user couldn't accidentally do. And what we're going to do with those detection points is we're going to feed that information back into kind of a centralized store somewhere in the application and keep track. So if the user does something bad, in portion A of the application, then in portion B, and then comes back and does something else in portion C, we keep track of all of those things, and we hold it against the user. Because at some point, we're going to define a threshold, and we're going to say, all right, we're really confident that after 3 events that we have confidence in, each of them in themselves, that you're definitely up to no good, and now we're going to take action against you. We're going to kick you out of the application, or we're going to lock your account, or we're going to email an admin, or call you, or whatever we want. The point is, you use your threat model and your tolerance for risk, and you decide how you're going to respond to these actions when the attacker is determined to be, a malicious entity. Now, this works really well in the authenticated portion of the application because, like I said, you can log out the user or lock their account. And once you've locked the user's account, in theory, they can't get back into the meat of the application, the authenticated portion. Now, if you don't have any control of user account creation, then this doesn't work too well because they'll just create another account and come back in. But still, you are stopping an attacker, or you're making it very difficult to the point where they might want to just go away and attack somebody that's a heck of a lot easier. Now, on the outside, unauthenticated portion of the application, you can still use these types of ideas to at least alert you to an attack. And maybe you could take an alternate approach, like sending an email to an admin, or even using some sort of IP blocking type setup to try and thwart that malicious entity. So the idea, as I've mentioned, is it takes an attacker a lot of different probes and attempts to find a vulnerability. As you know from attacking apps yourselves, as we're all pretty experienced in that area, it takes a variety of different attempts to find a flaw. Probably 10, 15 attempts, and even in one page if you know of a particular flaw in that exact page. So if AppSensor, if this idea can detect you as an attacker within, say, 3 of those, I'm guessing that we can say you're bad and we can get you out of the application before you find a flaw, if it happens to exist in any particular page. And so this is that whole other layer of protection. We build the app secure, and that's great. That's what we have right now. Build it secure to make sure we don't get compromised. But then add in this entire other layer, that police patrol type approach, the tripwires in your application. So you figure out who's bad and you get rid of them. And this helps because even if you don't know about the vulnerability in your application, what you're looking for is the badness of the user. And you can find that using these deviations from normal flows and the attack patterns. So this is where I think we should move. Right now we're building secure, and we're doing lots of different things. We should continue to do that. Developer training, security throughout the SDLC, penetration testing, all that stuff is great. But let's move forward and also actively defend our applications from attackers by using detection points, monitoring trends for anomalies, and then taking action against these attackers to stop them from doing the bad things they're intending to do. Now the question comes up of why do it this way? We have other solutions out there that attempt to do this. There's WAFs. Some people say, well, we monitor logs, we look for attacks in this way, and those things have their merits, but I don't think they have as much power as this approach. And one of the big differences is building this type of idea into your application. It allows you to interact with, for one, the user object, so you can actually lock out the user. But it also lets you understand specific application context. One of the big areas that most standard tools cannot defend or even test well is access control. A device that's outside of your application, it won't know if ID equals 4 is an attack. But inside your application, it will, because it gets an access control exception. It says you shouldn't have done this, and I'm going to count that against you as a possible attack. Again, it depends on how your application is designed, but that's one way of doing it. You can add that as a potential attack from the user. WAFs, they can do their thing, but it's a generic type solution, and you have a custom app, so you're only going to get so much merit from that. And as anyone that's done lots of log analysis, it's not something you can do quickly or really that effectively across the board. So that's the idea of AppSensor, and that's why I think it's very powerful and a really good move. What we're going to talk about now is how you can take that concept and actually use it. So AppSensor was designed in Java, and it's ready to be integrated into ESAPI. When we designed it, we also wanted to make sure that if you chose not to use ESAPI, which is fine, that you could still use AppSensor. And so AppSensor is set up that way that you can extend some of the classes, and you can modify it to work totally with or without ESAPI. But right now it's ready to use. We've built applications with it. There's a developer guide that's available to help you actually get it going. And it's planned to be bundled into ESAPI Release Candidate 8. So soon, if you're using ESAPI, once you're just downloading ESAPI on its own, it'll be there too. And this tool, we'll say, it's not really just a pie in the sky type idea. I mean, it is actually being used. Mod Security is building integration with AppSensor. They're taking the theory of AppSensor, the detection points, and building that in. A major insurance company, as I found out, is making it standard that all apps that are being developed from this point on will use ESAPI, and they'll also use AppSensor style detection points with AppSensor code. And that's awesome. I'm really pumped about that from this point forward, all of their apps have to have it in there. So that's pretty exciting. And at Mozilla, we're using these concepts. We're not using the AppSensor code specifically, but we're using these concepts of attack detection. And I'm going to talk about that a little bit later. And also, ESAPI has a pretty large and strong user base, so I'm excited that once this gets rolled into ESAPI itself, it's going to get even more adoption. So the the AppSensor jar right now, it's drop-in support. So just bring it into your application. It takes 3 lines of configuration in the ESAPI properties file. Then you also get a AppSensor properties file, and this is where you're going to decide what is our threshold and tolerance for risk. We have these detection points in our application to detect these attackers. How confident are we in their false positive rate, and how aggressive do we want to respond? So you define those in this properties file. And then the developers, they add 2 to 3 lines of code to make this work. That's it. So if you think about how this could actually work in your application, you sit down and you do your threat modeling, and you say this is a point of attack that we should detect. You tell your developers that you want to use this here. They go into the code, they add 2 to 3 lines. That's it. It's working. That's relatively readable from 5 feet away. So here's some examples of how to set it up. You just make a quick change to your ESAPI properties file to use a different intrusion detector. And then you define your AppSensor properties. And what you see here is the intrusion detector. This is one of the codes that we use. X1 is not a real code, but there's lots of different codes, about 50 different detection points that are defined, and each of them have an individual code. And so you can define your properties and your thresholds per instance in the application. So you could have it detect input validation and type attacks one way in one part of the application. You could have different thresholds in a different way if you wanted to, just by moving around the detection point codes. So you define your threshold of tolerance. So we're going to say after 2 events, we're going to take action, 2 events within 35 seconds. And here you get to define what you want to have happen. So in this scenario, the first thing we'll do is just log the event. This guy could be bad. Let's just log it. If he keeps doing it, 2 more in 35 seconds, we're going to log him out. And then eventually we can do other actions. In this case, disable component for user. So what we've decided is he's attacking a particular portion of the application, and we think it's better to turn off that functionality of that page rather than